quadratic formula and the discriminant. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. A degree 2 problem will always have two answers. That's why you have a plus or minus. That'll be two answers for x. We need to find out what a, b, and c are. Is this in standard form? No, so we have to put it in standard form. I need to put the 2 on the left-hand side, making it a negative 2 equals 0. We see that a is 1, b is 3, and c is negative 2. B, negative b, so that's going to be a negative 3, plus or minus b squared minus 4 times a times c, which is negative 2, all over 2 times a, which is 1. And then you just need to simplify. 3 squared is 9, and negative 4 times 1 times negative 2 is positive 8. At this point, I would use my graphing calculator to find out approximately what x is. X is approximately, because we have an irrational number here. If I was going to graph it, then I'd want to know those decimal answers. If I'm just doing a problem to show that I can do the quadratic formula, then this could be a final answer. On the graphing calculator, I need to make sure that I use parentheses to keep the numerator grouped together on a graphing calculator. Open parenthesis, use the negative button down bottom for negative, not the minus sign, negative 3, and we'll do plus the square root of 17, get out from underneath the square root, close your parenthesis, and then divide by 2. We get 0.56. So x is approximately 0.56. And then what I can do is I can recall this equation back. So if I do second, and down here it says entry. So if I do second entry, it brings back my equation, and then I can scroll over and put a minus sign for negative 3 minus the square root of 7. I can put in the minus sign, and then it becomes negative 3 minus the square root of 17. Here's the minus sign. So first you do the plus sign, and then you do the minus sign, hit enter, and we get negative 3.56. These would be the x-intercepts of the function. So if I was graphing, I would want decimal numbers, but if I was just solving the problem, then I would just leave this for my answer. All right, the next one, you want to shift everything to the left, negative 12x plus 9, negative 12x, so we have 25x squared minus 30x plus 9 equals 0. All right, I don't see anything here that can simplify, and so we're just going to use the quadratic formula again. Negative b, this time b is negative. Negative b, double negatives, plus or minus the square root. It's going to be important that b is in parentheses this time for b squared. The negative needs to be squared. Minus 4 times 25 times C, which is 9, all over 2 times A. All right, so we have 30 plus or minus negative 300 times negative 30 times negative 30 is going to be 900. And then a negative times a positive is going to be a negative. Then we have 4 times 25 is 100 times 9 is 900. So we get 900 minus 900 is the square root of 0 over 50. And so here we see x equals 30 plus 0 is still 30 over 50. We get 30 fiftieths, which would be 3/5. X equals 3/5. Because 0 was under the radicand, this time we only end up with one answer. Okay, for the next one, I am going to put my x squared on the other side. So 0 equals a positive x squared minus 4x positive 5. Negative b plus or minus b squared, negative 4 squared, minus 4 times a times c all over 2 times a. 4 plus or minus negative 4 squared is 16, and we have minus 20. 16 minus 20 is negative 4 over 2. The square root of negative 4 is going to be 2i. We see that we have 3 terms on the division bar here. So is there something that I can reduce all 3 of these terms by? I can reduce by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. 2 divided by 2 is 1. And we get that our final answer is 2 plus or minus I over 1, which is just 2 plus or minus I. We have an imaginary number here. All right. Now, based on our answers here, we can use a discriminant to let us know right off the bat how many answers that we expect to have. The discriminant, you're looking for the discriminant, we're looking at b squared minus 4ac. The discriminant can tell us exactly how many x-intercepts that we have. If the discriminant, when I do the b squared minus 4ac, if that is greater than 0, that means that I'm going to have 2 real solutions, 2 x-intercepts, and that will be 2 real solutions. If I look at this example, I see that my discriminant was 17, which is greater than 0, and I had 2 real answers. If my discriminant equals 0, then I have 1 real solution, 1 x-intercept. So here we see that our discriminant was 0, 900 minus 900 was 0, and we ended up with 1 answer. And finally, when we have that the discriminant b squared minus 4ac is less than 0, that means imaginary numbers, and you're not going to have any x-intercepts. It's not going to be crossing the x-axis. That would be 2 imaginary solutions, and that is what we got on the last problem here. We had our discriminant was less than 0, and we ended up with 2 imaginary solutions. Okay, so when an object is dropped, we've talked about this before. We have h equals negative 16 t squared plus h of 0. Negative 16 has to do with gravity, pulling on the object. We know that we have the initial height, h of 0, and then we have the height above the ground. What does it mean to have an object that is launched or thrown and not just dropped? We still have gravity pulling on the object, but now we have v of 0, velocity, v of 0 t plus h of 0. And so v of 0 is velocity. What is the difference between dropped and launched? Well, thrown has an extra term. V of 0, which is the initial vertical velocity. How does the formula show this? Well, if the velocity is greater than 0, then we know that it's being launched upwards. If the velocity is less than 0, then we know that it's being launched downwards. And if the velocity is equal to 0, then we know that it's launched parallel to the ground. Let's apply this. A juggler tosses a ball into the air. The ball leaves the juggler's hand 4 feet above the ground and has an initial vertical velocity of 40 feet per second. The juggler catches the ball when it falls back to the height of 3 feet. How long is the ball in the air? So we have this juggler, and he launches a ball. Ball goes up. We know that it's in the juggler's hand 4 feet above the ground, so this would have to be 4 feet. And when he catches it, it is back to 3 feet. It has a vertical velocity of 40 feet per second. All right, so the ball goes up, comes back down. We have that h equals negative 16 t squared plus v of 0 t plus h of 0. We know the initial height is 4. We know that it has a vertical velocity of 40. And we know that the height above the ground is going to be 3 feet. All right, let's get all of our terms on the same side. 0 equals -3 minus 3. And then we can try to factor to see if it will factor, or we can use the quadratic formula. We can complete the square, but this section is about using the quadratic formula, so let's use the quadratic formula. X equals negative b plus or minus b squared minus 4 times a, which is negative 16, times c, all over 2 times a. All right, grabbing my graphing calculator. I have open parentheses to keep my numerator grouped together on the calculator. Open negative 40 plus the square root of 1664. Get out from under the radicand. Close your parenthesis and divide by negative 32. So we get x equals negative 0.02. And I'm going to recall it back and do the minus sign. So recall, scroll over, put a minus, equals 2.52. So we reject because time can't be negative. Therefore, it had to be in the air for 2.52 seconds. All right, we're going to take a look at the discriminant. Find the discriminant of the quadratic equation and give the number and type of solutions of the equation. All right, for problem 1, we see that A is 2, B is 4, and C is negative 4. So B squared minus 4 times A times C. And we get 16 plus 32. The discriminant is 48. That means that we will have 2 real solutions because the discriminant is greater than 0. And now I'm going to find out what x is. X equals negative b. Find the discriminant and give the number of type of solutions of the equation. And so this should be plus or minus here. Plus or minus the discriminant of the square root of 48 over 2 times a. 2 times 2 is 4. And again, I'm just going to use my calculator. Open parenthesis, negative 4 plus square root of 48. Get out from under the radicand. Close my parenthesis. Divided by 4. So we get x equals 0.73. And then I'm going to recall it back, re-entry, entry, blue, entry, over and change the plus sign to a minus sign, enter, negative 2.73. Problem 2, I need to shift these to the other side. So 4x squared, we have add 3x is 6x, minus 3 is going to be 9, equals 0. A is 4, B is 6, and C is 9. The discriminant is going to be B squared, 4 times A times C. The discriminant is negative. Therefore, it's going to be 2 imaginary solutions. All right, let's find those imaginary solutions. So we have negative b, which is going to be negative 6, plus or minus, the discriminant was negative 108, all over 2 times a. 2 times 4 is 8. All right, we need to reduce 108. All right, so the square root of 108 is equal to the square root of 4 times the square root of 9 times the square root of 3. So here's the square root of 4, the square root of 9, and we can see there's a 3 left. So we get 2 times 3 times the square root of 3. That would be 6 square roots of 3. All right, so we have -6 plus or minus 6 square roots of 3 all over 8. And again, I can see I can reduce all three of these terms by 2. And our final answer is going to be -3 plus or minus 3 square roots of 3 over 4. And there was a negative in there, so that's 3i here. -3 plus or minus 3i square roots of 3 over 4. And the last one. Let's see, it's all set up for us. So A is 3, B is 12, and C is 12. Get 144 minus 12 times 12 is 144, so we get 0. The discriminant equals 0, so there will be one real solution. All right, so we have x equals -b plus or minus the square root of 0 over 2 times 3 is 6. And so we get x equals -12 divided by 6 is -2. One solution. All right, factor to find the x-intercept. So here's our function. X squared equals 4x minus 5. So we have f of x equals x squared plus 4x minus 5. And it says to factor to find the x-intercepts. Set it equal to 0. Factors of 5 that add to 4 would be 5 and 1. And that would have to be +5 and -1. 5 times -1 is -5, and 5 minus 1 is +4. Use the quadratic formula to find the roots. So this one says factor to find the x-intercepts. So what would the x-intercepts be? We get x equals -5 and +1. We could use the quadratic formula to find the roots of the solution. -b is going to be -4, so we get x equals -4 plus or minus b squared minus 4 times a times c, which is -5, all over 2 times a, which is 1. All right, so we have x equals -4 plus or minus 16, and that's going to be a plus 20. 20 and 16 is 36, all over 2. So we have x equals -4 plus or minus the square root of 36 is 6 over 2. So we have x -4 plus 6. 6 minus 4 is 2. And 2 divided by 2 is 1. And then -4, -6 is -10. Divided by 2 is -5. Which is what we expected because we just found the same answer over here, but we factored. So that's good that our answers came out the same. They should be. Use the discriminant to determine the number of real zeros. How many real zeros? So if I look at the discriminant, and the discriminant is b squared, 4 squared, minus 4 times 1 times -5. We found out that the discriminant was 36. It's greater than 0. All right, our discriminant is greater than 0. And so we know that we have 2 real solutions. I would say concave up or concave down. Which way is this facing? It's a positive parabola, so it's facing up. So this is concave up. The axis of symmetry, x equals negative b over 2a. X equals negative 4 over 2 times 1. So we get x equals negative 2. So the axis of symmetry is x equals negative 2. And then the coordinate of the vertex would be f of negative 2, substituting that back in. Negative 2 squared plus 4 times negative 2 minus 5. 4 minus 8 minus 5. So we have negative 4, negative 5 is negative 9. Our vertex then is, when x is negative 2, we got negative 9. The vertex is a minimum. The y-intercept is negative 5. When x is 0, we would get negative 5. Number of zeros, 2. The zeros that we have are negative 5 and 1. We need to graph this. So we know at negative 2, our intercepts were at 1 and negative 5, 1, 2, 3, 4, 5. And the vertex, 1, 2, 3, 4, 5, 6, 7, 8, 9. The y-intercept is negative 5, 1, 2, 3, 4, 5, negative 5. We definitely have enough information here to, I have my vertex labeled at negative 2, negative 9. I have my AOS labeled. I have my intercepts all labeled. Solve by completing the square. So we have x squared plus 4x minus 5 equals 0. We are going to isolate our x terms and put our constant on the other side. Leave room to complete the square. So we are going to add to each side. We're going to half the b term and square it. I need to add this to both sides of the equation. So 4 divided by 2 is 2, and 2 squared is 4. So I added 4 to both sides of the equation. This is a perfect square trinomial. And so we get 2 times 2 is 4, and 2 plus 2 is 4. So we have x plus 2 squared equals 9. If they wanted it in vertex form, then I would just shift the 9 over and it would be in vertex form, but here it says to solve. So I'm going to finish solving. I am not going to expand this out. I'm going to start by undoing the square. Going to square root both sides, plus or minus square root, and we get x plus 2 equals plus or minus the square root of 9 is 3. X equals negative 2 plus or minus 3. Negative 2 plus 3 is 1. Negative 2, negative 3 is negative 5. And again, we can see that we can complete the square, quadratic formula, and we can factor. All 3 of these are how we can solve for the x-intercepts. The domain of this would be from negative infinity to positive infinity, all the reals. The range starts at negative 9 and goes to infinity. It includes negative 9, so we'll put a square bracket. And then a rounded bracket for infinity. Those are all of the things that you can do with a quadratic. Solving quadratic function.